Hi friend, in this video I will discuss OLS method of estimation in econometry. Okay, OLS method of estimation is the most important method of econometrics. Entire econometric theory move around OLS method. Okay, in order to grab the clear concept of OLS method of estimation, you need to watch my video till end. In this video I will cover what is the OLS method, what is the differences between the OLS method and regression method. Okay, and before moving on video, I would like to request you, if you come first time at my channel, please subscribe and press bell icon for all notifications so that you will get my latest video notification easily. Now let us begin. What is the OLS method? OLS stands for ordinary least square method. Okay, and as we know that what is the differences between regression equation and OLS method? And suppose that I am supposing regression equation and line of y on x. This is equation. Okay, here relationship is the deterministic and systematic. Okay, and in regression model, okay, in regression equation model, where for the given value of xi we can predict value of dependent variable yi with the given value of parameter a and b. Under OLS method we estimate the parameter of regression model, that is the a and b are interested to deriving and getting the value of a and b. And how it happen, how the parameter value is estimated. Now let us start. First, suppose population regression function is given by yi equal to beta 1 plus beta 2 xi plus ui. Okay, here this is the population regression function, and it has a two component. First component you can see here. Okay, first component systematic relationship determining dependent variable and independent variable. Y is dependent variable, x is independent variable. Like suppose that quantity demanded is a depend upon price. Okay, here there is a systematic relationship q equal to a plus bp. Okay, it is the systematic relationship, and you can this past it is called a stochastic part error term of population regression function. Okay, we can predict this value. Systematic part is estimated, but error term is not estimated. Okay, we try to minimize error sum of a square in OLS method first. But you can see here, this is the population regression function. It is not observable. For that purpose we need to take sample regression function. You can see sample regression function. Y I predicted b1 plus b2 xi plus ei. Here disturbance term in sample regression function is denoted by yi. This is the sample regression model. This value is systematic. It has also two components. First component is the predicted value, and second component, that is the stochastic error term. Okay, suppose that law of demand, what is other thing remaining same? There is inverse relationship between the price and quantity demanded, and price and quantity demanded is a represented here. Price and quantity demanded is represented here, but error term representing a stochastic error term, that is the other thing being remains same, like choice of consumer, income of consumer, etc. Some factor is a measurable and some factor is a qualitative, that is it is not directly measurable. Okay, now what is the OLS method? Very simple. OLS method estimate parameter of the regression model, that is B1 B2. Okay, sample B can estimate parameter of regression models, sample regression model, sample regression function, and whatever the value we get in sample regression model, suppose that B1 B2 two parameter, so we know that expected value, mean value, expected value of both parameter B1 is equal to beta 1 in population regression model, beta 2 is corresponding beta 2, the expected value of beta 2 is equal to expected value of B2 is equal to true population value, population, that is the it is available in population regression function. Now what is the OLS method tell us? Okay, OLS method tell us it estimate parameter of regression model just okay errors, minimizing error sum of a square. In other word, it minimize sum of a square of differences between observed value and predicted value. Observed value and predicted value. This is the observed value and it is the predicted value, where predicted value is denoted by B1 plus B2 xi. This is the predicted value is systematic deterministic equation. Okay, here we can easily estimate for given value of x, we are able to get the predicted value of dependent variable y. Now start solutions. It is the background before learning of OLS method. Now what is the OLS method? It minimize sum of a square of differences between observed value and predicted value. And what is the differences between observed value and predicted value? Okay, equal to yi minus predicted. This equation is representing differences between observed value and predicted value. A squaring and summing of both sides. Okay, so summation of ei square, summation of yi minus predicted value of y square. Okay, it is we need to minimize OLS method minimizing. Okay, minimizing sum of a square of differences between observed value and predicted value. And for minimizing condition, first order condition, we apply here F4C. Taking the partial derivative, before taking the partial derivative, we need to substitute the value, predicted value, the value of y cap, that is the predicted value. And what is predicted value? Equal to B1 plus B2 xi. Substitute here. So now I am going to start here. This is the predicted value, sum of a square differences, summation of ei square equal to summation of yi minus the value of value of y cap equal to B1 plus B2 xi whole square. You know one thing, say predicted value, that is that it is describing and implying deterministic relationship between two quantity, between dependent and explanatory variable. Now solve it little bit, arrange it. Summation of E square equal to summation of yi, and I am going to break this bracket, minus p1 minus beta 2 xi whole square. And we know that what is the minimization condition? First order derivative equal to 0 and second order derivative greater than 0. So first we are going to take the first order derivative, and we are going to take the partial derivative of summation of E square with respect to parameter b1 b2. The first are setting into equal to 0. Del summation of I square with respect to b1 equal to 0. If you take the partial derivative of this function with respect to b1, we apply chain rule. We are applying chain rule to come summation of xi minus b1 minus b2 xi, and if we take derivative of term inside the bracket with respect to b1, we get as minus 1 equal to 0. This minus 1 into 2 become minus 2, summation of xi minus b1 minus b2 xi equal to 0. Okay, and both side dividing by minus 2, it become minus 2 and 0 minus 2. It become 1, that is summation of yi minus b1 minus b2 xi equal to 0. This becomes 0. Now now need to do applying a break this bracket, applying of summation side. Summation of yi minus b1 is the constant. Okay, now only we can put here summation sign. Here minus b2 summation of xi equal to 0. Okay, and there summation equal to n. One thing, only variable take the summation side. Okay, parameter don't take it. Now shifting all minus term in RHS side, summation of yi equal to b1 equal to n. So we can write it summation equal to n. It become positive, it moving into right side. Now n b1 plus b2 summation of xi, it become equation number 1. Okay, this become equation number 1. Now first order derivative, we have a partial derivative we have taken. Now it is a time to check this thing. Suppose that this term is already we have here. Okay, a term we get here. Suppose that we are not dividing both side by minus 2, and if you take the derivative, the second order derivative, that is del 2 summation of yi square with respect to b1. Second order derivative we are taking here must be SOC, second order condition must be greater than 0. Okay, now minus 2 is already here and minus 1 coming here, and minus into minus plus 2 is always greater than 0. That is hence the second order condition for minimization is satisfied here. And now we need to take the partial derivative of error sum of a square, that is summation of E square with respect to now b2. Okay, only b2, and setting equal to 0. Now b2 setting equal to 0. Now 2 is coming first, summation of yi minus b1 minus b2 xi, and if we take partial derivative of in a term inside the bracket, we get we are taking partial derivative with respect to b2. Here we get minus xi, okay, equal to 0. Minus into 2 minus 2 summation of xi b1 minus b2 xi times xi equal to 0. And if both sides are dividing by minus 2, okay, here the term becomes 0, here the term becomes 1. Okay, now summation, and if this entire term is multiplied by xi, it becomes xi yi minus b1 xi minus b2 xi square equal to 0. And giving summation sign, assign each of the term here. Summation of xi yi minus b1 summation of xi, now b2 summation of xi square equal to 0. And shifting these two term into RHS side, all become positive. Here summation of xi yi equal to become positive if it move into the RHS side. Minus b1 summation of xi, plus b1 summation of xi plus b2 summation of x square. Okay, it become equation number 2. It become equation number 2. These are called the normal equation. Okay, now we need to estimate the parameter of regression model. We need to get the value of b1 b2. Now how it first from equation 1. First from equation 1, we are going to get the value of b1 and b2 from equation 1. You can see equation 1 is a given here. Summation of yi equal to n b1 plus b2 summation of xi. And both sides, if we divide by term n, dividing both sides by n, first divide it. Okay, here it summation of yi by n, it become mean, because mean represents sum of item divided by number of atom. Okay, so it become mean y equal to n cancel, b1 come here, b2 likewise, it become mean x. And we can solve for b1 equal to mean y minus b2 mean x. This is the value of parameter b1, population parameter b1, and we write another place for future reference. b1 equal to mean minus b2 xi. Okay, b1 equal to mean y minus b2 mean x. Now we need to derive the value of b2 with this simultaneous equation, with given these two equations. So very simply we need to eliminate b1 parts. Okay, and if we multiply first equation into summation of x and second equation n, we are able to eliminate b1. Okay, so now we are multiplying summation of summation of xi, summation of yi. Okay, n equal to n b1 summation of x plus b2, and here summation of xi and summation of xi times summation of xi, it becomes summation of xi ka whole square. Okay, this term is multiplied by second equation is multiplied by n. Now n summation of xi times summation of yi equal to n b1 summation of x plus n b2 summation of x square. Now it become, and eliminate, subtract this equation. First equation is a multiply by summation of x minus second equation is a multiply by n. Change the sign, plus minus cancel. Here we get summation of xi times summation of yi minus n summation of xi and yi. Okay, and summation first n summation of xi yi. Okay, here equal to b2 summation of xi whole square minus n b2 summation of x square. Okay, first we need to take here b2 is common, summation of xi whole square minus n summation of x square, and here it is written as it is summation of xi times summation of yi minus n summation times summation of xi yi, and b2 equal to this term is a b2 equal to this term is a divided by this term. Now write down summation of xi summation of yi minus n times summation of xi summation of yi, and this term summation of xi whole square minus n summation of xi square. Okay, now little bit arrangement is needed here, and we are arranging this term, and n times minus n times summation of xi yi is the putting first term, minus n summation of xi yi, this term become it is a positive summation of xi yi, and likewise minus n summation of xi square minus plus summation of xi whole square. Okay, if we take minus common in from numerator and denominator, it become like this, minus I have taken as the common, minus it become positive, and positive item become negative, summation of xi yi minus summation, or 1 minute, n times summation of this term separately summation, yes, minus summation of xi summation of yi, and in denominator minus we are taking as a common summation of xi square minus summation of xi whole square, minus minus cancel, and one term we get, we are going to write here, making the space. Now b1 we have a calculate equal to b1 equal to mean y minus b2 mean x, sorry, b1, and b2 equal to whatever the term we get here, n times summation of xi yi minus summation of xi summation of yi, and in denominator summation of xi square minus summation of xi whole square. Both parameter b1 b2 is estimated. If we get the value of b1 b2, easily we can estimate true population value, okay, beta 1 beta 2, because expected value of b1 equal to beta 1 true population parameter, and expected value of b2 equal to beta 2, okay. And you can also put it deviation form. This can be written, now this can be written as it is, b2 equal to summation of xi minus mean x times summation of yi minus mean y, and here summation xi minus mean square, and it is a need to prove it how it become. And suppose xi equal to small xi equal to xi minus mean, yi equal to yi minus mean. Now in deviation form it can retain summation of xi yi divided by summation of x square, okay. This is in deviation form. Now we need to prove it, and b2 in numerator part denoting covariance, and denominator part is denoting standard variance of x, okay. Covariance between x and y is represented by the parts in numerator, and standard variance of x is represented by term available in denominator, and we can prove it. This would be suppose that we are going to take variance term. First part we are going to take numerator part, covariance of between x and y, okay. Summation of xi minus mean times yi minus mean, okay. First thing we need to multiply here. Xi is multiplied by yi minus mean is multiply yi minus mean y. Now, and here xi yi minus mean xi minus yi mean y, minus into minus plus mean x mean y. It is read as x bar y bar. Now placing the summation sign, summation of xi yi, here is x bar representing mean of y, it is the constant term, okay. Mean y summation of xi, and likewise mean x is the constant summation of yi, and here summation both are constant terms, summation equal to n, we have already seen. So n yi xi, Okay, suppose that we are multiplying this term and summation equal to n xi yi. Now summation of xi yi now minus summation of yi by n times summation of xi minus summation of xi by n times summation of yi, and here plus n summation of xi by n summation of yi by n. 1n cancel. Okay, so suppose first 1n is the left, and here we take LCM in this four term. N is coming as a numerator, n times summation of xi yi minus, as it is a written rearranging of this term. First I am writing xi and second summation of yi, and again once again a summation of xi minus summation of yi, and here plus summation of xi times summation of yi. Plus minus cancel, and the part we got in numerator is a very similar, but one thing is a divided by n, and if we get the second denominator part of this equation, everything will be clear to you. Okay, the first thing we get here n summation of xi yi minus summation of xi yi by n. This part, it is the part of numerator. Okay, n denoting numerator part. Now we need to second part, the denominator part, the term consisting and available in denominator. Only then we will able to n cancel, both part we are going to n. Now second part here, summation of xi minus mean whole square. First a square xi square minus 2ab plus b square mean square, placing summation sign, summation of xi square minus 2 mean summation of xi, the term having observation. Okay, variable term take only summation sign, plus n summation is a coming and mean square. It can be written summation of xi square minus 2x mean xi plus n mean into x bar into x bar. It can be written x bar square, and we know that summation of xi minus 2 mean summation of xi plus n times mean, and mean xi equal to summation of, it can be written summation of xi by n, sum of item divided by number of item. Okay, take the LCM. So x square, okay. If we take the LCM, n times summation of xi square minus 2n x mean summation of xi plus n summation n times mean x summation of xi by n, and this term is a reduced. First 1 second, n times summation of xi square, and this term become n times mean summation of xi by n, and we know that here n mean equal to summation of x. We can easily derive it. mean equal to summation of xi by n. Cross multiplication n times mean equal to summation of xi, and substituting value here. Now n summation of xi square minus summation of x, again this term becomes summation of xi, and again multiply this term summation of xi by n, and now it can be finally written summation of xi square minus summation of x whole square by n. And already we got the value of numerator and denominator, and we can easily prove it. Okay, how it become a covariance between x and y and variance of x. Okay, now we have taken numerator term. We are going to write this term in summation of xi square minus summation of xi whole square divided by n, and already we have derived the term in numerator n summation of xi yi minus summation of xi times summation of yi divided by n, and solve it, simplify it. This term is written as it is, as it is. Okay, summation of xi yi minus summation of xi summation of yi n, and this n moving into numerator n times summation of xi square minus summation of xi whole square. N cancel. Now it can be written, which is equally b2 equal to now n times summation of xi yi times summation of xi summation of yi. Okay, and this term is a cancel. Okay, and this term is a written summation of xi square minus summation of xi whole square. This value is exactly equal to beta 2, and we have a proof it. We can write this covariance of between x and y divided by variance of x in place of this term. And I hope everybody got the concept I discussed under this video. I try my level best to making it so simple to understand those students having no mathematical background. And if you come first time, once again I remind you, please subscribe my channel in order to enjoy video like this, and never forget to comment what kinds of video you want to see and you would expect from me. Thanks for watching my video till end. Jai Hind.